So now we'll go through the example number 3 and we'll understand one more concept about the double integration. So double integration 1 upon y raised to 4 plus x square dx dy over the region y is greater than or equal to x square and x greater than or equal to 1. So here the terms in x are 1 upon x raised to 4 plus suppose constant, some constant, but we know that 1 upon x raised to 4 plus alpha cannot be integrated by any method, whereas the terms in y are 1 upon y raised y square plus some constant that can be integrated using the tan inverse formula. Okay, so it is clear that it is not possible to integrate with respect to x first by any method, so it is compulsory to integrate with respect to y first. Now we'll go through the area of integration. So here area of integration is the area bounded by the parabola y equal to x square. Since x square, the parabola is symmetric about y axis, the parabola is drawn. Okay, and the line x equal to 1, this is the line x equal to 1 is drawn. Now we want to understand what is the meaning of this y greater than or equal to x square. So this is the origin. Okay, let me consider a point which is outside the parabola, right? Y greater than or equal to x square, it means that the area will be inside the parabola or outside the parabola. So I'll consider one point inside the parabola and one point which is outside the parabola. So let me consider this point. This is x equal to 0, x equal to 0, y equal to 0 origin. This is x equal to 1. Let me consider x equal to 4 here. The point is on x axis, therefore 4, 0. So we want to check whether for this point y is greater than or equal to x square or not. Okay, so the point is 4, 0. Okay, that gives x equal to 4, 4 square is 16 and y equal to 0. So is it true? No, 0 cannot be greater than 16. So it means that we don't have to consider a point outside the parabola. Now let me consider a point inside the parabola and we'll check it. Okay, so let me consider a point which is on the y axis. So say point is 0, 3. Okay, so x equal to 0, y equal to 3. Let me find y is equal to 3. Let me find x square, x is 0. So is 3 greater than 0? Yes. So meaning of y greater than or equal to x square means points inside parabola. So all the points which are inside the parabola, all these points. But this is not the only restriction. We have one more restriction. X should be greater than 1. So this is the line x equal to 1. X equal to 2 here, x equal to 3 here, x equal to 4 here. So x greater than 1 on this side. So their intersection of these two areas, the points which are inside the parabola and greater than 1 is this area. So this is the area of integration. Now see the line x equal to 1. So x coordinate is x coordinate of point A is 1 and the point is intersection of x equal to 1 and y equal to x square. So when I substitute x equal to 1, I have y equal to 1 square, that is 1. So this is the point 1, 1. Since the point is up to infinity, so here x equal to 1 final point, y will be equal to infinity. This point is, the parabola is up to infinity, so it is actually infinity. Understand this, huh? The point is infinity. Now we want to find the limits. Already we understood that we have to integrate with respect to y first. So integration with respect to y first and then with respect to x. Outer limits are limits of x, therefore minimum and maximum value of x. So minimum value of x is 1, maximum value of x is infinity, that we understood from here. Okay, so now limits of y. So consider a strip which is parallel to y axis. This is the strip. Where the strip starts? Strip starts from the parabola. So what is the value of y on the parabola? Parabola is y equal to x square. So y equal to x square is the lower limit. And where the strip ends? At the infinity. So upper limit is infinity. Hope you might have understood all these things very well. Okay, so limits are x equal to 1 to infinity, limits of y are x square to infinity. We have to integrate 1 upon y square plus x square. Whenever we are integrating with respect